Unit 3, Level 2, Lesson number 1. And our first topic is solving one-step equations with addition and subtraction. And the essential question we're going to be looking at today is what is the connection between inverse, balance, and solving equations? Let's begin by making sure we all have the same understanding of an equation. There is nothing magical about an equation. It's simply a statement of equality. And what that means is that both sides of the equation have the same value. By the way, make sure you're filling in the blanks on your notes as we're going through this. So everything that's in yellow should be written on your notes. So by equation, I'm really just making a statement about two expressions and saying that they have the same value. So it's if you look over here, I have x minus 7 equals 8. And that equal sign simply means that x minus 7 has the same value as 8. And equations only have one solution. So that means that there's only one number I can put in here that will make x minus 7 have the same value as 8. Now we can do this in our heads. If we think about it, 15 minus 7 equals 8. But equations are going to get more complex than this. So rather than solving them in our head, this lesson is about using inverse and balance in order to solve all kinds of equations, not just the ones you can do in your head. A key strategy for solving equations when you're not going to solve them in your head is to manipulate the equation by calculating, to get the variable by itself on one side of the equal sign. So that means you take the unknown and you manipulate this equation until the variable is by itself, and then you can get the value of that variable. We do this with two key ideas, inverse and balance. By inverse, I mean inverse operations. If you want to undo an operation, you do its inverse. The inverse of operation of addition is subtraction, and the inverse operation of subtraction is addition. The other concept you need to keep in mind is balancing. An equation, again, is a statement of equality. The two sides may look different, like 1 plus 1 does not look like 2, but if you add 1 plus 1, you have the same value, right? 1 plus 1 is 2. So these two sides have equal weight, equal value. If I mess with this side here on the left, that's going to change the value of that side. In order to keep it equal, I have to also do the same thing to this side. So the key concept related to balance is this. If I change one side of the equation, I have to make the same change on the other side. And the fill-in that your notes that goes with that is what you do to one side of the equation, you must do to the other side. Otherwise, the equation is not balanced anymore. So let's look at an example. Example 1, x plus 7 equals 15. Now we could do this in our head. If I look at and I think about what number, right, some number plus 7 equals 15, I know that number is 8. But let's use our two concepts of inverse and balance to solve this. First, draw a line down where the equal sign is to show your sides. Remember, the equal sign separates the left side and the right side. So draw the line all the way down. And then let's think about this. X plus 7. I have addition. I'm adding 7. The inverse of adding is subtracting. So I will subtract 7. Inverse operations cancel each other out or undo each other. So plus 7 and minus 7 cancel out, and I'll be left with x on this side. But remember, that's the inverse part of it. But now there's the balance part. I have messed with the left side of the equation. So now my equation is unbalanced. To make it balanced, what I do to the left side, I have to do to the right side. So I subtracted 7 on the left, now I subtract 7 on the right. So as you can see, my adding 7 and subtracting 7 cancel out. I'm left with x on the left-hand side, which is what I wanted to do. I wanted to get the variable by itself. And on the right side, you subtract 7 or 15 minus 7 equals 8. So the value of the variable x is 8. For each problem, we want you to check your work. So the way that you check your work is you take your solution, you found a value, x equals 8. How do we know that's right? Well, if it's correct, I should be able to substitute it back in to the original equation, and my two sides should be balanced. Well, let's think about it. If I take x equals 8 and I substitute that back in here, so instead of x, I write 8, then that should have the same value as 15. And sure enough, if you add them together, it does. X plus 7, or 8 plus 7, equals 15. So this side has the same value as this side. Finally, we want you to graph your solution. Remember, the solution is the value of x. So in this case, I want you to graph at x equals 8. You simply find 8 on your number line here and put a circle, or put a dot, and label it x equals 8. Example 2, 40 equals x plus 25. Again, we have addition, so we think about the inverse of addition, which is subtraction, and since we added 25, we're going to subtract 25 underneath, and then what I do to one side of the equation, I must do to the other side in order to keep it balanced. So on the left-hand side here, 40 minus 25 is 15. And adding 25 and subtracting 25 cancel each other out. And I'm left with x by itself on this side, which is what I wanted. Now, if this is arranged strangely to you to say 15 equals x, you are welcome to flip it around and say x equals 15. It means the same thing. Next, we want to check our work. How do we know that this is correct? How do we know that this is the value that works to balance this equation? Well, if we take 15, and again, we substitute it back in for x, right? So instead of 40 equals x plus 25, we write it like this. 40 equals 15 plus 25. If I add 15 and 25, I get 40. And so we have proved that the right-hand side of the equation has the same value as the left side, 40, when x equals 15. Finally, graph your solution. You will put a dot at x equals 15. Example 3 is subtraction. X minus 5 equals 16. So in this case, I will do the inverse of subtracting. I will add 5. And what I do to one side, I must do to the other. So, subtracting 5 and adding 5 cancel each other out, and I'm left with x by itself, which is what I wanted. And on the right-hand side, I add 16 plus 5 equals 21. So my solution is x equals 21. I check my answer. I take 21 and I substitute it in for x and see if that equals simplify it to see if that equals the right-hand side, if it equals 16. And sure enough, 21 minus 5 equals 16, so my two sides balance. And then you graph your solution and it's at x equals 21. Let's look briefly at inequalities. So far, we have only looked at examples that include equals, and equations only have one solution. Inequalities have many solutions, right? If it says less than or equal to, greater than or equal to, you can have many solutions to a problem. Now, be aware if it says less than or greater than, that means that you're going to write your answer using a hollow circle here at the number. So like if your solution is x is greater than 3, or pardon me, less than 3, that means that the solution is all numbers less than 3, but it can't be equal to 3. So you leave the circle open is what we call it. It's like a hollow circle, and then you shade in everything to the left. If it's less than or equal to, like here, less than or equal to 3, that means that 3 can be a solution, so you do a closed or filled in circle. So let's look at an example. X is minus 2 is greater than 12. We solve these exactly the same way as equations. So again, I think, what is the inverse operation of subtraction? It's addition. So instead of subtracting 2, I add 2. And what I do to one side, I must do to the other. So here, minus 2 and plus 2 cancel out, and I have x by itself on the left-hand side. And on the right-hand side, 12 plus 2 is 14. Make sure to bring down the greater than symbol. So my solution is x is greater than 14. That means that it's all the numbers greater than 14. So when I graph this, I start on the number line at 14, which will be about right here, but I'm going to put an open circle. Why am I going to put an open circle? Because 14 is not included in the solution. This is x is greater than 14. So that means any number bigger than 14 can be a solution. So again, I start at 14, I put a hollow circle, and I shade everything to the right, since the solution is all the numbers bigger than 14. Example 5, y plus 9 is less than or equal to 6. I see addition. The inverse operation of addition is subtraction. So I subtract 9 from both sides. And then plus 9 and minus 9 cancel out. I'm left with y on the left-hand side. And be careful here on the right-hand side. I'm starting at 6, and then I subtract 9. That's not possible if I don't include negative numbers. Right? So when I subtract, I start at 6 and I go to the left. Think of it kind of like on the number line. If I were to start at 6 and go to the left, 9, subtracting 9, right? Minus 1, minus 2, 3, 4, 5, 6, 7, 8, 9, you end up over in the negatives. So 6 minus 9 is negative 3. To graph that, since the solution is y is less than or equal to negative 6, I would use a closed circle at negative 3. Since it's less than or equal to negative 3 can be a solution. So I do a filled in closed circle, and then I shade to the left since it's all the values less than or equal to negative 3. Make sure you fill out your summary. It should answer the essential question, and it should be 4 to 5 sentences and include the important vocabulary, including inverse, balance, and equations.